Hello. This is Germany, so we start right on time. That's interesting. And I will be really bad probably at keeping track of time, but you will be helping me. One reason maybe you will be doing so is that first person, would ask a question. Maybe you will get a kite. So I need to leave time for questions at the end. There's plenty of talks tonight that I hope I will not spoil, so I will try and talk about everything, but the kind of things that you will hear about later tonight. Maybe first, quick show of hands. Maybe first, like who's from Grand Centrics, I guess. Okay, not so many. So many people coming from outside. Who's embedded developers? Okay, well, pretty much everyone. Okay, I don't need to ask the other questions then. You're in the right place. We're going to talk about Zephyr. So who knows Zephyr then? Like kind of a broad question, half of the room. Okay, cool. So Zephyr is this operating system, or I mean, and we can talk about that, whether calling it a real-time OS really does it justice. We can call it a distro, maybe, in addition to being an operating system. It's really a lot of things that help build the kind of embedded software you would find in a wide variety of applications and in a wide variety of devices, from really, really small, like healthcare, like hearing aids sort of devices, to really big, and all the way from like consumer to very much industrial and like big machines and wind turbines and things like that. And in no particular order, if we were to try and sort of summarize what Zephyr is all about, is really trying to provide this kind of abstraction to embedded software developers that provides them with all the flexibility they need in terms of making sure that you are not as much as possible, not writing code that's going to be depending on a particular piece of silicon or piece of hardware, especially in those days of like silicon shortage, etc. It's actually quite important. And so no matter what kind of vendor you're going to go for in terms of your actual MCU or like the sensors that you want to use, Zephyr is going to help you bring this kind of abstraction. It's going to bring you all the services that you need also to try and like have security in mind as much as possible. And there's some tips that I will try to share as part of the presentation in terms of what you can do to get help from Zephyr and the Zephyr build system, etc., to get a sense of whether your code is secure and like capture things like your software bill of materials for those familiar with the topic. And it's small, but small doesn't mean that it cannot scale. So you can get Zephyr in really, really small, think Cortex M0 sort of devices with very little amounts of flash and RAM. You might not do a lot, but you will still get this sort of nice kernel and this nice abstraction of your underlying hardware. But you can scale to pretty big, and like I said, industrial machines and wind turbines and sensor networks. And in case you didn't know, I have actually a couple slides coming, but you will find Zephyr in laptops even, and that you maybe didn't know. It's open source, so I'm Benjamin, by the way, Benjamin Cabé, or Benjamin, based out of France, and I work at the Linux Foundation. I work like literally for the Zephyr Project, and a bunch of colleagues here, like Susan, same. We're from the Linux Foundation. We look after making sure that Zephyr is and remains an open source and vendor neutral community where everyone gets to play a role, basically, and try to have all the governance in place, and that also, I will try to cover in a couple of slides towards the end of the presentation. And it's all about the ecosystem, and that's why we're here tonight. Feature-wise, I have way too many slides there. So one way to look at it, again, is Zephyr. You can call it an OS, a real-time operating system. It's probably more than that. It's really, and if we were to look at like really from a distance, it's providing you with the abstraction, the hardware abstraction layer that oftentimes comes, a lot of it comes from the silicon vendors themselves, and Zephyr would add just enough on top of it to be like really agnostic and as independent as possible from the underlying hardware. And then you have the kernel that provides you with the really what helps you write code that's not a super loop, pretty much, to summarize it. Like with the gist of the kernel services would be things that help you essentially write like have multiple threads running on your system and things like that. But that's, yeah, I guess that's the RTOS, right? Like trying to have like a rock solid scheduler and like those kind of low level primitives to do synchronization and have tasks talk to one another. You don't necessarily get very far with just that. I mean, you can still write super like critical, safety critical software that's going to run in a timely manner, etc. But how about like you want to write a GUI? You're building an IoT device, so you're going to be interested in Bluetooth. You're going to be interested in Wi-Fi, Zigbee, whatever. So that's where basically Zephyr adds on top of those layers high-level services, like and really it becomes more of an application framework, if you will, where you will be able to pick. And we can talk about how modular things get by taking things like kconfig, from example, from the Linux world. Like you cherry pick whatever functionality you're interested in the Zephyr ecosystem at large, in the Zephyr distro, I guess, for the lack of a better word, and you pull those libraries and those subsystems to build your application. And like I said, Zephyr you will find in a lot of products. So it's, by the way, a call to action for all of you who might be building products on top of Zephyr. You might not always be able or willing to share that particular information publicly, but if you are, please ping us at this particular URL. Just fill in a form and let us know where you're using Zephyr. And like I said, you would find Zephyr in wind turbines from Vestas. Like they have like these super complex algorithms for managing like the way the turbine actually generates electricity and monitoring all the faults using CAN bus. This is all based on Zephyr. You have tons of wearables, like I said. So yeah, consumer devices, you will find it certainly a lot. Industrial gateways, you want to have like a ruggedized gateway that bridges everything to everything in terms of like Ethernet to Wi-Fi to cellular to whatever. You will find quite a few that are based on Zephyr, and more that's not showing here, like I said, laptops. I'm not sure any of you guys familiar with the framework laptops. There you go. It runs Zephyr. Did you know that it runs Zephyr? Now you do. It actually comes originally from the Chromebooks. Chromebooks, they have this this open source embedded controller firmware, which allows to basically manage the laptop when it's not running the main OS, when it's basically in standby. You still want to control the battery charge. You still want to control what happens when someone presses a key and things like that. So that's the embedded controller from Chromium. So Chromebooks, they ship with Zephyr, and framework laptops, which are a super nice, like super modular laptop architecture and laptop manufacturer, they basically forked and reuse the same embedded controller firmware, which happens to be Zephyr-based and open source too. So that's pretty cool. In terms of boards, basically, so you all raised your hands. I'm sure you have drawers full of those guys and full of dev kits. It's likely that you pick just a random one and it will just run just fine. If you try and run Zephyr on top of it, we have 600 plus, I think, boards that are supported all across. I'm not sure I actually mentioned that, or at least I didn't say it. It doesn't have to be ARM only, right? I mean, obviously, many of these here would be more or less ARM and Cortex-M based, but it doesn't even have to be Cortex-M. Like you could also look at Cortex-A, Cortex-R, Espressif, even beyond just ESP32, like all things Extensa. Like there's not only Espressif that does things based on Extensa silicon. You have RISC-V and x86 and pretty much all the hardware architectures are supported, which is pretty nice to see as well. Sensor-wise, same. Like if the sensor you're interested in interacting with, be it a temperature, barometric, whatever sensor, is not supported already, it's likely that you can just reuse or like adapt an existing driver and get rolling in little with limited amount of effort. So it's also nice in terms of hardware abstraction. And one thing I will try to talk a bit about the roadmap and things that recently landed in Zephyr, things that are keep getting added over the releases. But one area that's pretty active these days is making it easier to simulate and emulate sensors, which is also quite interesting. You might not always have the actual sensor handy. You still want to do some integration tests and figure out your GUI and things like that. There's also a framework that allows to do that. There you go. That was the hardware architecture slide. What did I not mention? Yeah, we have support for MIPS, for ARC, and a bunch of others as well. Like I said, it's all about the ecosystem. I will talk a bit about that, especially this sort of maybe quite vague or maybe hard to grasp area in the middle, things where, people don't always get or understand how you run an open source project such as Linux or Kubernetes or Zephyr. There's a lot that happens in terms of governance, etc. So I will try, without being boring, hopefully, to sort of give you a bit of insights into how you can sort of combine hey, everything's on GitHub, we're all having lots of fun hacking the code as individuals, but then there's also big companies that are trying to make money on top of Zephyr. So how do you combine the two? Architecture-wise, that would be one way to look at it. I think hardly any of you probably can even read what's on the slides. The slides are online though, but basically the same kind of layers that we were seeing earlier, except that it has a bit more, we dive into a bit more details, which I will be really quick here, but essentially I will make a parallel, which might or may not make sense depending on where you're coming from, but think about the Arduino ecosystem where whatever you want to do, there's likely a library out there that's going to help you do the job. It might not be crazy good in terms of quality, it might not be maintained, etc. But you can really easily, at least feature-wise, things are there. Therefore, that's pretty much the same. Whatever you want to do in the context of an embedded application, including graphical user interface, all things networking, all things storing data on a file system, etc. All those services and subsystems, they're there, but they are actually all sort of well integrated with one another, well integrated with the underlying Zephyr concepts. So when you try and do something like networking and you want to do TCP/IP or co-op and lightweight M2M to do device management and over-the-air firmware upgrades, you get Zephyr native, if you will, implementations that will leverage all the great things that come from the foundations underneath, like Zephyr's power management functionality, Zephyr's hardware protection, stack protection, you name it, functionality. This is all built on top of the Zephyr infrastructure. So that's for connectivity. There's a native IP stack that keeps getting improved and keep getting sort of refreshed and up to date with regards to latest evolutions in all the standard, the well-known ones, I guess, the DHCP and SNTP and things like that, but also if you're building a gateway, an actual gateway, there are other protocols that you might be interested in leveraging, which are also implemented in Zephyr. One thing that's interesting to mention as well, and I will tell a bit more about that in a different context, but the fact that Zephyr, in some ways, is similar to Linux in that, you're writing code in C, you're writing code targeting devices that, sometimes are way too small to run, or most of the times are way too small to run Linux, but you're writing low-level code that interfaces with hardware. One thing that's interesting to be able to do is take existing drivers, existing code that you may have written for Linux. It might require some adaptations in terms of making it more lightweight and things like that. But if you have code that happens to be written against BSD sockets APIs or just in general POSIX APIs, it's likely just a matter of recompiling it and it will just work on top of Zephyr. You have an existing library for decoding whatever, proprietary protocol coming over UDP, I don't know what, it will likely just like whatever code you have that expects to talk to UDP sockets that you can just run on top of Zephyr. All things Bluetooth, we have people in the room tonight from Nordic, so like lots of the Bluetooth questions you may have, I will certainly encourage you to talk to the Nordic people. But yeah, like effectively, all things Bluetooth, Bluetooth low energy. There's lots of one thing that I really love about the Zephyr, the Bluetooth support in Zephyr, is the fact that you have tons of code samples that you can just like reuse. You want to build something that sorts of like a heart rate monitor, like a BLE heart rate monitor. Like you need to use the right BLE profiles and whatnot. Like just take the heart rate monitor example that's already in the Zephyr code base and start building on top of that. BLE, yeah, I mentioned. USB, same. There's basically one of the main. Where is Johan? Raise your hand, Johan. Like, oh, he's hidden right there. Yeah. This is one of the guys who make USB a reality in Zephyr, both from like a device and a host perspective. So lots of stuff happening there, and like whether you want to build some device that behaves as a mass storage device or something like a more keyboard/mouse kind of device, or USB audio, you want to build a headset. Those things are available, right? Power management, that's something that's actually quite interesting. The way Zephyr is built and the way the Zephyr kernel works means that you have a way, like whenever you write code on top of Zephyr and whenever you leverage existing drivers, etc., oftentimes those drivers, they have hooks in them to properly handle what should happen when you want to go to sleep. Like when you want to go to sleep, that particular I2C sensor and that particular I2C bus that you're using when you're doing something, you want to turn it off when the device is going to go idle. And that's, yeah, there's basically an entire framework for power management. And whether you're targeting, again, ARM or other architectures, it's there for you to leverage. Speaking of Linux concepts, I think I briefly mentioned kconfig before, which is what we use to make the Zephyr code base modular and make sure that you pull only the bits that you need when you want to compile your actual binary. One thing that's also coming from the Linux world is device tree, where basically all the hardware capabilities of the hardware that you're effectively putting together, like this particular board and design and PCB that you're assembling, it's going to be one or several SoCs with that maybe require particular like specific configurations. You will be pulling in sensors that you're attaching to your different interfaces. You will have, I don't know, like an LCD display that you're going to attach to your SPI bus, blah, blah, blah. All that you can describe like in a very clean and central way so that most of your drivers basically will be getting their configuration options right from this configuration file, and a lot of like the checking whether your actual hardware configuration can even work. Like a lot of it can actually happen at compile time. Like, oh, you're trying to use a particular sensor that doesn't, like, you're trying to hook it up to a bus that's not properly configured or not properly hooked up to this particular clock. Careful, this sensor will probably not work in your code, sort of stuff. Security in terms of enabling things like having a dedicated bootloader so that you can only you can check like what kind of application you're trying to boot and whether it's actually allowed to run, right? And having root of trust and assigned firmwares so that you can make sure that people run trusted software, and if you want to do over-the-air upgrades, rolling back to a working version of your firmware if the update didn't work properly, right? And this is something that's hooked into systems like lightweight M2M. Like this is certainly a pretty popular standard for all things cellular, and so you might have like a cloud platform that allows you to manage a fleet of devices using the lightweight M2M protocol. Or there's the Hogbit project as well, which originally came from Bosch and hosted at the Eclipse Foundation. Integration with hardware security. Should you have secure elements on your design, you can leverage that. Like you want to do like hardware accelerated crypto functions. You can leverage that. You can integrate with trusted firmware, etc., etc., etc. Like I said, I have way too many slides there. POSIX quickly. This one is sort of twofold. And that's literally the two main top-level bullet points. One is, and that's super efficient when you're writing code and you want to like test locally that your things work. You don't even have to build your app against your final like ARM-based or whatever MCU. You can actually compile against Linux and run your application. Plus or minus maybe some actual like hardware dependencies you might have, but like most of your application you will be able to run in a simulated, if you will. I mean, I guess I'd rather call it native Linux application, right? The file system APIs, they will be hooked up to your local file system APIs, etc., etc. And the other way around, there's also this thing where Zephyr can run on top of a POSIX compatible OS, and Zephyr can act as a POSIX compatible OS and allow applications that run and are built on top of Zephyr to use things like sockets, like I said, and all the APIs for opening and closing files, and the APIs for semaphores and you name it, right? And there's a lot that's happening in this area to make sure that we get to the point where Zephyr is effectively like fully POSIX compliant. That being said, like if we go back to the very bottom of the stack, yes, there's this ecosystem of like this distro, like I called it, and all those services and subsystems that I mentioned. But at the end of the day, you may want to use Zephyr only for like the real-time kernel and the handful of source files that effectively make up the core of the real-time OS, and with the scheduler and the ability to create threads and do context switching, etc. And we need to get to the point where we sort of use standard benchmarks to make sure that we're really comparing things that can be compared. But in a nutshell, like Zephyr is also an efficient RTOS. Good thing, because we typically refer to Zephyr as Zephyr RTOS. GUIs, quickly, briefly, there's display drivers in Zephyr to interact at a low level with LCD displays and e-ink displays, etc. But manipulating like screens and GUIs pixel by pixel is fun until it isn't. So you may want to use a more high-level framework such as LVGL, which happens to like just work and be pre-integrated as a module that you can pull and start building on top of. And so any board that's supported in Zephyr and that comes with a screen or that to which you can attach a screen, you can leverage LVGL on top of it. And with things like the recently added input subsystem, it makes for a pretty nice software development experience in that you really end up writing a GUI as if you were like writing Java or .NET or whatever, like high-level desktop code almost. Like you really manipulate your button interactions and your touchscreen interactions and your actual GUI widgets with the kind of APIs that you would expect from a regular desktop or web GUI framework. Tons of options and I mean, I don't need to go into many details there, but you can get either really, really low level when it comes to making sure that your different tasks and different components in your system synchronize with one another and talk to one another. Or you can also leverage things like ZBus. And there was recently a webinar about ZBus, which I will be plugging in a moment. But yeah, it's sort of like a high level abstraction of how would you make tasks and process, not processes, but yeah, different tasks in your system talk to one another, either like really with a one-to-one sort of approach, or it can be one-to-many, many-to-many. It's pretty new, but it's pretty powerful in terms of developer support and developer tools, integration with tracing frameworks, and you can do debugging and like enable, there's a very advanced logging framework as well. You may want to log on the UART for sure, but there's also, you can log on the file system, you can log over Bluetooth as well, I believe. It's pretty versatile in that way. And last but not least, I could almost have started with that, but there's also, in addition to just the code that hopefully you are already using or you will look at using at some point, there's really all the infrastructure to also help you actually structure your projects and your applications, things like West to help you like have literally a manifest of all your dependencies and make sure that you version the different dependencies that you're pulling in when you're building an app. Things like Twister to help you write unit tests and write and run unit tests and integration tests, which you may or may not run against real hardware. You can also run against simulators such as Renode. And yeah, how am I doing on time? Really bad. That's good. No questions, no kites. Sorry. Okay. Yeah, and so like this is really just almost just name dropping, but we do releases every 4 months, and there's always a ton of stuff that keep coming in. So those things recently made it in the October release, the ability to make applications modular at runtime, like literally loading a dynamic module or dynamic library, if you will, at runtime, which in the context of over-the-air upgrades and things like that can be pretty cool. Using PyColibc for smaller footprint in terms of like pulling in a standard C library that's smaller, integration with code analysis tools, and maybe a bit into what's coming. So stay tuned. We're literally just a couple weeks away from the next 3.6 release. So there will be tons of cool stuff. The input subsystem that I briefly mentioned, we'll see lots of new additions, network services, the ability to sort of declare whenever you want to have several co-op endpoints or several HTTP endpoints in your application, having a way to sort of declare them in a more declarative way, as opposed to writing a lot of boilerplate code. I will be sharing the slides. So safety and security, we do a lot to make sure that the code base allows for safety certification, basically. And so there's a lot of work happening in both the security and safety working group to make sure that, well, one, we do long-term support releases. If you are building a product on top of Zephyr, chances are you don't want to leave off the main branch of the Git repo. You want something that's hopefully more stable and will be maintained on the longer term. So that's what we do with the long-term support releases, just like, Ubuntu, etc. You're probably familiar with that. So this would be like basically every 2 years or so, we tag a release and we commit to maintaining it for the next 2+ years. And so whatever security vulnerabilities that may happen will be always sort of backported to this branch for at least two years. And the next long-term support release that's coming will be around the June timeframe with the one after next Zephyr version, the 3.7. Let me see. I'm going to skip lots of slides. Yeah, you're all making fun of me, and for good reasons. My bad for keeping the slide deck so huge. In terms of ecosystem and governance, so briefly, the way Zephyr has been around since 2016 as an open source project. The code is actually older than that. And since 2016 under the umbrella of the Linux Foundation. Essentially, those companies, those platinum members, in addition to the silver members here, the way it works is that they are effectively members of the Linux Foundation. Every year, to be super concrete, they pay membership fees that go towards making sure the ecosystem around Zephyr is thriving. Because when you're a Nordic, a Google, a whoever basically is on this list, like when you're starting to bet your business on Zephyr, it's one thing to, I mean, Zephyr is free, it's open source, so in many ways, those companies should be fine, right? They take the code and so be it. But they actually want to make all they can so that in 5 years' time or 10 years' time, Zephyr is still around for there's a community that keeps growing, etc. And one way to encourage this is share the load and share the effort, including from a money perspective in terms of doing lots of marketing and making sure that we have like good infrastructure. For what it's worth, like a lot of the money that the members are putting into Zephyr, it goes into things like paying our Amazon bill every month for doing continuous integration. And who wants to make a guess? Maybe you get a kite for whoever is going to be the closest. So we have, I think about, let me make sure I get this right. For each release, we get about 500 people contributing code. Every week, we get hundreds, actually a couple hundred of pull requests merged every week. And for all those pull requests, we run CI/CD. So how much do you think our AWS bill is every month?
50K?
It's more in the range of 10K, if I'm not wrong. But it's a lot. Like and it makes sense to share this among all the members, right? And there's of course many other things that go into the budget. Things like security, safety certification, Bluetooth certifications, things like that. So yeah, that's basically how it works. And then we try and make sure that there is a thriving ecosystem of tools for developers, so you don't have to. I mean, I know that many people use VS Code, but there's also like you can use Sea Lion from JetBrains, Eclipse, etc. to develop your applications. Tons of tools for profiling, etc. that are compatible with Zephyr. Tons of companies offering training, and I think we need to update that one because there's actually quite a few others out there that provide training, etc., etc. So. Yeah, and with that, what? We can talk afterwards. That's also, hopefully, you will still be around. Next, few events coming up. FOSDEM. I think some of you tonight are actually coming all the way from Belgium. But hopefully see you at FOSDEM. It's pretty nice hacker event. First weekend of February in Brussels. We will be at Embedded World. We will be, of course, because that's our event, in Seattle mid-April for the Zephyr Developer Summit. We are online like we do every week these days. Tech talks about Zephyr. If any of you would like to be a guest on the show and share about some cool things you're building with Zephyr, well, you will be my guest, basically. Zephyr weekly updates, if you Google that one, or if you tune in on Discord, you will get updates that I'm trying to put together every week, going through all those 200 plus pull requests so that you don't have to, and trying to sort of extract what are the cool things that came that week in terms of new drivers, new SOC supported and whatnot. And those are a few more links to find us online, but you probably know them already, I would hope. Discord is definitely like the last one. We have like thousands of people on Discord, and that's where usually, if you ask a question, no matter what time of the day or the night it is, you will get someone helping you in minutes usually. So that's what I had, and hey, not too bad. Questions? So there's kind of a kite for whoever said 50K, I guess. Who else? Like who? Yes.
I need to persuade some colleagues.
Right.
Can I get these slides somewhere?
So, question is to help convince some colleagues internally where to get the slides. They are pretty much right on the homepage of the Zephyr website. Off the top of my head, I think it's zephyrproject.org/overview. That is also a shortcut for those slides, or at least, I mean, mildly adapted them for tonight, but and you can. I have some business cards as well. I'm also happy to help in terms of talking to your colleagues. And I mean, there's lots of questions or like misunderstandings that also may sometimes be in people's heads with regards to, oh, yeah, it's open source, like it's going to be tricky. We will have to open source everything. It's, by the way, the license is Apache. I didn't mention that, but when you use Zephyr, you don't necessarily have to sort of like contribute back or share, like give the source code of whatever you're going to be building on top of Zephyr. It's not like it's GPL, right? So yeah, and I want to be mindful of the other speakers. So maybe the other questions. Oh, yes, please.
It's not a question, more of an idea. I mean, Google is a big member of Zephyr as well, right? Couldn't you just run the pipeline on like Meetup and get it for free?
Question is, this will be on record. The other question is, in terms of CI/CD, getting some help from some of the members to get some funding. Yeah, it didn't happen yet, but it could, I guess, because it's all like Kubernetes abstracted, etc. So, but yeah, it's certainly a lot goes into making sure that we have a great infrastructure, so that when there is a new contribution, we do tons of checks to help make the lives of the reviewers and the maintainers easier, and make sure that we keep the code quality high as well. Like every week, we run code coverage analysis and tools like Coverity to find potential bugs, like by doing lots of like static code analysis. And interesting. I wanted to go back further, but yeah, that's one of the slides that I skipped before. I mean, take it with a grain of salt, but that's interesting to look at the sort of the health of Zephyr as an open source project compared to other open source RTOSs out there, like Amazon FreeRTOS, or the recently open sourced now Eclipse ThreadX. So things will probably change here, but in the meanwhile, like you take the average number of unique contributors per month for Zephyr, and you add the number for all the others that are listed there, and it doesn't get even close, right? Similarly, number of commits, whatever that means, please take it with a grain of salt. Like a commit can be really small or really big, and maybe those guys, they do huge commits less often, but still that also gives sort of an indication of where things are going. And yeah. Please take it with a grain of, like I mean it. Like it's, they are not here to be like we're the best. It's just we might not have captured the right data there, but it looks yes.
One question: there was a slide with the memory footprint. I think scalable from 8.
Yeah.
Was that just a kernel? Or was that a full?
Yeah, so like the minimal footprint, and we actually, that's part of the things we check in CI/CD. So the question is with regards to the footprint that was mentioning. Few kilobytes of RAM and flash. That's for pretty much Hello World sort of application. I don't know off the top of my head. It does slightly more than that. It does like maybe a bit of like semaphores and things like that. But it's sort of the minimal things that we can reasonably call Zephyr. Like it's yeah. So maybe not.
Slightly more than the kernel.
Yeah, like the kernel plus some kind of application that does something reasonably useful, plus also like the actual whatever pieces you need to pull from the hardware abstraction layers of whatever vendor. So the footprint might also vary depending on how smart and how efficient whatever the libraries are for like dealing with the clocks and the UARTs and the basic things. Right, great questions though. So lots of kites too. I said first person, but maybe I think we have a few. Yeah, and I'm way out of time, right? Right. So there you go. Other questions that would be either at the short break around 8-ish, I guess, or when we're done. Thanks, everyone.